Good morning everyone. Today I will be taking the topic of full wave rectifier. Full wave rectifier is a type of rectification which uses two diodes. In this, the load current passes through the resistor at the same time. It uses two diodes because it can work efficiently. When one cycle is going through forward bias in this diode, another the negative cycle will be going through this. So we can achieve maximum rectification. So I will explain with you. So this is the figure. As I said, it uses two diodes D1, D2. Then here got an AC input. It will be going through this and it will be separated. Then we have got a load resistance. So this type of rectifier is known as center tap rectifier, which is commonly used because it only has two diodes. We have studied this in our previous classes, school days. So so when the current flows, that is when the current goes through the AC and it will be going through this coil and it will be split into two waves. So when the first positive wave comes through it, let's say A will become positive. The terminal A becomes positive, B becomes negative. So the current goes through and it will become positive bias and we get that positive output. Okay. Then for the next, this negative one, what will happen? It will be inverse. A will become negative, B will become positive. So what happens? The forward bias occur in D2, resulting in another what graph towards the positive. So this will continue with another D1, another D2. So another one. So this is the output of what? Center tap rectifier. So this is the center tap rectifier and it is the most commonly used one. So we will get the output from this area. It is this is known as the center tap. This RL is known as the load resistance. Okay, so this is the center tap rectifier. So to find the peak inverse voltage, that's the maximum inverse voltage which we can find in the center tap rectifier. Let's assume that this one, the potential difference between this is Vm, this also be Vm. Then the PIV, okay, the peak inverse voltage will be 2 into Vm. Okay, peak inverse voltage will be 2 into Vm across the secondary windings. So the next topic is bridge rectifier, the second type of rectifier, full wave rectifier, which we are going to study. So in this, instead of two diodes, we have got four diodes: D1, D2, D3, and D4. The other setup are all same. We got our load resistance, which is the V output. This is a ground wire. So in this, the same things happen. When the AC current is passed through this, in the first, that is when the first cycle, first positive half cycle comes in, only D1 and D3 will be conducted. That is, D1 and D3 will be only having the positive bias. Okay? Both D2 and D4 will be on negative. When the current comes, it will go through here and conduct, that is have a positive cycle and will be stored come to here. Then the another voltage from there will be going and it will be stopping here. So this is the way in which what the first positive cycle works. So in the output, same output, positive will be coming when D1 and D3 is coming. Okay. On the another, this negative half cycle, what will happen? D4 and D2 will be conducting forward bias. Then we will get another one. Likewise, we can conduct. Okay, this is full wave rectifier which contains four diodes. That is the bridge rectifier. So this is what happens when we get this positive when this cycle becomes this. So the thing happens is that there is a small current which will be coming from the load resistance, which will go through D3 and you get through the coil, then it will reach the D1 and finally it will be rectified. So this is a simple topic in which this is the figure which explains how D1 and D3 is forward biasing. Okay, here only D1 and D3 is been conducting. So this is the figure. We can draw the same one for what D2 and D4. Okay. So next we are going to find out the efficiency of full wave rectifier. So for that, let's say that the efficiency I equal to V by R plus RL. Here RF is the diode resistance and RL is the load resistance. So we can rewrite V as Vm sin theta. And this is the same R plus RL. Okay. So now we have got what the efficiency. We can write the efficiency is I is equal to Vm sin theta by R plus R. So then next we are going to find out the DC output. Okay, the DC output. As you all know, this rectifier, so it will transform AC into DC. So we will be getting the DC output. DC out. For finding the DC out, we have an equation which is IDC equal to 2 Lm by pi. Okay. So this is the equation IDC for the DC current I. So for the DC output, we just need to DC output is equal to I square DC into R. Okay, so we can rewrite this as 2 Lm by pi the whole square into R. This is the equation for the DC output. Okay. So now we are going to find the resistance, which is the RAC. So we can find RAC is equal to I square RMS into RF plus R. Okay. I square RMS plus into RF plus R. So IRMS, as you all know, IRMS is equal to IM by root. Okay. So we can substitute this. So we will get PAC. So PAC is equal to IM by root 2 the whole square into R plus R. Okay. So we have now got the PAC and we found out the PDC, which is the DC output. So if we can compare the both output and input, what you can get, we can get the efficiency. So now we will be substituting this in that equation and finding out the efficiency. So efficiency equal to EDC by EAC, which is equal to 2 Lm by pi the whole square into RL the whole divided by I by root 2 R of plus R. So on finding this out, we are squaring this, we will get 8 by pi square into RL by R of plus RL. We can rewrite this as 0.812. On finding this out, this value becomes 0.812 into RL by R of plus R. Then what we are going to do is that we are going to bring this RL to down, so we can get that 0.812 by 1 plus R by R. Okay, we are dividing this both, so the RL and RL both cancel, we will get 1 plus R by R. So then we are, this is a very small quantity, so this is a negligible quantity, so we are just neglecting it. We will get that 0.812. Okay, converting this into percentage, we find that 81.2%. So this is the efficiency of a full wave rectifier in an ideal case. So it is that if you compare it with the previous graph, from half wave rectifier we only got 40%. So we can find out that we can get the double of the efficiency of a half wave rectifier. So this is my topic. In this topic I have told you about what is full wave rectifier, about the two types, center and the bridge one. And then I told you about the equation regarding that, finding the efficiency. Simple way we need to find out the input and output. Just we need to divide it so we can get the efficiency. So that's my topic. Thank you.